Hi everyone, welcome to a second example from section 6.7, solving rational equations. In this particular problem, we have b over 4 is equal to b minus 22 all over 5b minus 35 minus 1/5. So as before, what we want to do to begin solving a problem like this is we want to find the least common denominator, or we abbreviate it as LCD. So recall that we had an example where we basically treated the denominators like children. We want to make sure that the kids all have the same kinds of things in their denominator in order to make them happy. So I'm going to go ahead and go through here and make a note. So 4 is the denominator for our first term here on the left-hand side. And note that in this case, I could break 4 down into its prime factors of 2 and 2. But if I kind of just skim over the other two denominators on the right-hand side, I notice that none of those factors are multiples of 2 or 4. So you can break it down into 2 times 2, but just note in this case it's not necessary. So if we move over to 5b minus 35, take a look at both of those terms, and do you see a common factor between the two? And hopefully you've noted that yes, 5 does work between those two. So if I factor out of 5, my binomial becomes b minus 7. Lastly, we have a denominator of 5 here, and 5 is a prime number, so I can't get around that. I can't break it apart. So I'm going to go ahead and kind of pull together a checklist to make this least common denominator. 2 out of my 3 kids here have a 5 in it, so I know that a 5 is going to be included. I also note that all the kids should have a 4, and lastly, all the kids should have a b minus 7. So I'm going to go ahead and rewrite the problem and then incorporate this common denominator after. So b minus 4, and I'm also going to leave some space in here so that I can do that all on the same line. And I'm going to leave that 5 times b minus 7 in its factored form. Okay, so let's go through and do the checklist. So first off, I know that for my b minus 4, it needs a 5. So I'm going to multiply the top and the bottom by a 5, and it needs a b minus 7. Okay. So let's move on to our next term on the right-hand side. It looks like it has the 5 already. It has the b minus 7, but it needs the 4. So I'm going to multiply the top and the bottom by a 4. And lastly, if we come over here, we already note that our 1/5 has a 5 in the denominator, but it does need a 4, and it does need a b minus 7. Okay. So the good news is that we've created a common denominator between all 3 of our rational expressions. Notice that each one now has a 4, each one now has a 5, and each one now has a b minus 7. So as before, or as had been discussed, whenever we're working with rational expressions, once you have that common denominator, you can essentially ignore the denominator. We're not canceling it out. We're just basically running a line saying, hey, you don't have to look there anymore. You don't have to, you don't have to look at it, touch it, acknowledge it. Now that you have that common, you use a common denominator in order to construct the necessary numerator in order to solve your problem. So I'm going to go ahead and move this up first off, and I'm going to clean up what I see, or just rewrite what I see up in the numerator. So I have b times 5 times quantity b minus 7 is equal to b minus 22, and that whole binomial is being multiplied by 4. So that's why I'm going to go ahead and put parentheses around it to remind myself that I'm going to need to do a distribution. Minus 1 times 4 times b minus 7. but this is all still kind of messy looking. So I'm going to rewrite this so that it's a little bit more familiar. So I'm going to do an intermediate step. So instead of b times 5 times b minus 7, I'm just going to use my commutative property and say that's going to be 5b times the quantity of b minus 7. I'm also going to use my commutative property to move my 4 in front of b minus 22. And I'm also going to take care of this multiplication straight away. So a negative 1 times 4 is going to be minus 4 times the quantity of b minus 7. Now we can go ahead and do a distribution. So on the left-hand side, we'll get 5b squared minus 35b. And that's going to be equal to, let's distribute that 4, so we get 4b minus 88. And then we're also going to distribute this entire negative 4 to each term in that binomial. So we'll get negative 4b plus 28. Okay, so it's starting to take a little bit more shape now. From here, I'm going to go ahead and focus my attention on cleaning up this right-hand side. I can combine like terms here. And notice that I do have a positive 4b and a negative 4b all on the same side, so they're additive inverses and will cancel each other out. So this is going to leave me with 5b squared minus 35b on the left-hand side, so I haven't done any changing here. And if I combine a negative 88 and a positive 28, again, since they are on the same side of the equation, I'm going to get a negative 60. So this problem is starting to take shape, and it's probably starting to look like one of the problems that we've done back in Chapter 5. So I'm going to add 60 to both sides under the assumption that I can maybe factor this down. So this is going to give me 5b squared minus 35b plus 60 is equal to 0. And what I want you to note here is take a look at the coefficients. They're all multiples of 5. So again, I'm going to move this up a bit so we can see. And I'm going to factor out that 5. And let's see what we have left. That's going to give me b squared minus 7b plus 12. I don't know about you, but I think that's a lot easier to look at and to kind of keep track of, especially since the numbers are so much smaller. So the one thing that I'm going to do really quickly is this 5 might kind of bug you. If you want, this is completely optional. We could divide both sides by 5, since 5 is being multiplied by that entire polynomial. And notice now that we're just going to have b squared minus 7b plus 12 is equal to 0. Okay, so I'm going to go ahead and try to factor this down. And what I would recommend is that you pause the video and try to factor this down yourself, just to make sure that you have those skills down. But I'm going to continue. So in the upper left, b squared is going to go there. Lower right, positive 12. I know that my b's can be broken down to b times b. I know that I have a positive 12, but the middle term has to be negative. So a negative times a negative will cover that condition. A negative times a negative will give me a positive, and a negative plus a negative will give me a negative number. Now we need to think of something essentially, or two numbers that will multiply together to give us a 12, but will add together to give us a 7. I would suggest saying 4 and 3, and we can kind of double check that, remember? So we'll have b times negative 4, which is going to give us negative 4b, and then b times negative 3, which is going to give us negative 3b. If we were to add this up, we get negative 7b, which is what I want. So rewriting the problem one more time in its factored form, we'll have b minus 4 times b minus 3 is equal to 0. And we can use our zero product property then to make the argument that if b minus 4 times b minus 3 equals 0, then b minus 4 equals 0, or b minus 3 equals 0. If we solve for b, we will conclude that either b is 4 or b is 3. Okay. we are essentially done here. These are our two solutions, but what I would recommend is let's go all the way back up here, and I just want us to check, not that color, you can't see that probably too well. I want us to check to make sure that those two solutions of b equaling 3 or 4 doesn't cause our denominators to zero out. So as we can see in our initial problem, a denominator of 4 and a denominator of 5, they don't have a variable in there, so there's no risk of them zeroing out. But we should double check our denominator of 5b minus 35. So if we put 3 in for b here, notice that we do get 15 minus 35, or we would have a denominator of negative 20, which is good. As long as your denominator does not zero out or become 0, that is a good answer to have. If we now try for 4, we would get 20 minus 35, which would give us negative 15. So again, the denominator would not be 0 in that case. So to conclude, because this was quite a problem, our two solutions would be b is equal to 4 or b is equal to 3. I hope this video was helpful. If you have any questions, please let me know.